Hi, it's Sam. In this video, I wanted to revisit the groove object, partially to do a little bit of a variation on the code that I had shared before, but also to add a couple features that I think are useful. The first is a UI object that lets you set the loop start and end points, and the other is adding enveloping to the signal so that you can smooth out any clicks or pops that happens when you change the loop start and end. So let's get started. I'm going to begin with the code to add the sound file to a buffer that'll be read by Groove using the live.drop object. And out of live.drop, we will be getting the name of the sound file that's been dropped into it. If you want to save the sound file with your patch, you'll need to turn initial enable on. However, if you do that and then you don't save a file with it, or if you don't put a file into it in the first place, maybe I should say, then next time you open it, it'll send out the word none from the left outlet. So to get around that, because I don't want to send the word none to buffer, the buffer won't understand that, I'm going to use the select object and tell it none. And when it gets that value, rather than using the left outlet, which would send me a bang when that matches that, I'm going to use the right outlet, which just sends out the input if it doesn't match. So basically this should send out the name of a file, but if there's nothing loaded into it, then it will just not send out anything because I'm not going to use the left outlet. So from here, we can then send the message replace along with the name of the sound file to a buffer, which we need to name. I'm just going to name it Groovin. However, after it's loaded into the buffer, there's some information that I want to get about the file. And I'm going to use info tilde to get that. And I just need to give it the buffer name that I'm going to be getting information about. And the right outlet of buffer sends out a bang when the sound file has been loaded into buffer. I'm going to use that bang to then query the info object for the information that I want. I want to know two pieces of information. The first, I'm going to use sends and receives for this, is the total time. And the second is the number of channels. So total time is here, number of channels there, and we'll see how I'm going to integrate this. But I should be able to now put in my file and get the file name, set it into buffer, and then get the information about the number of channels for that file and how long that file is. Now let's add Groove. And we just need to tell Groove first the name of the buffer it's reading from, Groovin, and the number of outputs, which I'm going to say 2, because I want to be able to read stereo files. I'm going to turn some attributes on as well. I'm going to use loop. I'm going to use loop 1, turn looping on. I'm also going to turn on time stretching, and I'm going to use the 1 as well for that to make sure it's activated. And for the time stretching mode, I'm going to say general. And for quality, I'm going to say good. Okay, so now Groove should be set up the way I want to use it. And let's now add in the UI that I'm going to be using. And for this, we're going to be using Waveform tilde, which views the contents of a buffer. And we need to tell it which buffer to look at. So I'm going to use a load mess here so that I can automatically get this when it loads up. And we need to give it the message name, followed by the name of the buffer, which we named Groovin. I'll put this into the left inlet and then lock and double click load mess so that it will go into waveform. Okay. Now, we can also use waveform to not just view, but also set the loop end and start points. So using the third outlet, which is a selection start, Can put that into the loop minimum of groove, and then taking the selection end, I can then put that into the loop max. We also need to change the current mode of waveform by right-clicking on the first inlet. Can go to set mode, which by default is 0 or none, and change the mode to 2, which is loop. Now it should be able to load in a sound file, and it should be able to view it in waveform and then set the loop points. So let's try that now. I have a kind of test sound file. Okay, so it's showing up, and if we lock the patch, we can click and drag to place the loop start and end points where we want, and then we can drag upwards to make it larger, and drag downwards to make it smaller. And this will set the loop start and end point for us. Now I grabbed the total time earlier, and I'm going to show you what I want to do with that. I'm going to turn it into a receive here, and I'm going to send this to the third inlet, which can take a list of the selection start and end. So we can just create a floating point here. This will save the total time for us so that we don't need to retrieve it every time we want it. And we can just use a bang to send it out. And we're going to send this to a puck object, as it's pronounced, I believe. And this is going to get a 0 for the starting point because I don't want it to start at the very beginning. And then the ending point, I want to be the total time of the file. So let me pop that in there. And right now it shouldn't have it saved because I added this code after I had loaded in the sound file. So I can just send a bangs info now, and it should send it. Yes. So now let's test this out if this is working. I'm just going to make a smaller one, go over here, and it's working. So I'm going to call this reset loop points. So I've got a quick way of resetting the loop points if I want to be able to do that, which is useful. Now let's just add the other elements of the code that we have seen before. First is the playback speed and direction, which if you remember, we need to use a signal to drive groove. And I'm just going to use a floating point box here. And for convenience, I'll add a message of 0 and 1 so that I can quickly play and stop. And I'll just call this speed and direction. Also remember that negative values play in reverse. I also want to add pitch shifting like we had before, except this time I want to do the pitch shifting in cents. So if you're not familiar with cents, there are 100 cents in one semitone. So we're going to put this in cents, and to do that, we just say pitch shift cent. That was a $sign. And we'll need to multiply this by 100. Make sure to put the period after the 100. So doing floating point math. And now I can represent this pitch value in semitones, but I can get kind of microtonal sounds because I can add in intervals that are smaller than a semitone, which is fun. So let's also add in code to ensure that it will play back correctly if it's mono or stereo. And this is why I grabbed the number of channels before. And we need to use a selector object with the argument of 2. We're going to have 2 inlets. And the number of channels will open up the associated inlets. So if it's one channel, then the first inlet will be open. If it's 2 channels, then the second will be open. And this will be just sent to live.gain as the right channel. The left channel will always be active. If it's mono, it'll just be the left channel, and then the right channel will be silent. And if that's the case, we're going to need to copy the left channel into the right output. However, if it's stereo, then the second output channel will have audio on it, so we'll just want to send that through. And so number of channels, this will correctly select which input needs to go to the output. But we'll just need to, again, send a banged info to get that sent here. So it's 2. And now we can add an easy DAC and see if everything's playing correctly. And just make sure that we turn it down. Always want to protect your ears. Okay, seems to be playing correctly. Now, as I promised, let's add in enveloping. And how are we going to do that? We're going to use the rightmost outlet, which is the loop sync output. Let's take a look at what comes out of here. Using live.scope. You'll see it's a phaser that is timed with the start and ending point of the current loop. And this is really useful because we can just use this to drive a wavetable. So we're going to use the trapezoid object, which is a trapezoidal wavetable. And I'm going to start off by giving it 2 arguments, 0.1, which is kind of like the slope going up, and then 0.9, which is the slope going down. And I'm going to send that to the trapezoid object, which expects to get a phaser coming in between 0 and 1. We'll also take a look at what it looks like when it's coming out. And then all we need to do is multiply the signal by this envelope. Okay, now we should have enveloping, and if we want to adjust the slope of the trapezoid, then we can add in floating point boxes to the other inlets. Let's see how this sounds now. You notice that it still can be a little clicky, but if we were to adjust the slopes, we might be able to get rid of some of that. It kind of depends on where you are in the sound file. If you're in certain parts, especially where there are like transients, I think it gets a little bit harder to, if those get cut off, I think it gets a little bit harder to smooth those out. And also we can adjust the slope here. It's almost like a triangle. So in this way, we can add some enveloping, and what I think is useful about the trapezoid in particular, well, it's easy to set up, that's one thing, but when you have longer selections, it's kind of a sharp shape. It can be a sharper shape with the slope up and down, which means that the fades in and out are not as long, which again, for longer loops, like if I were to reset the loop points, it's not as noticeable. So let's play this back. There still is a noticeable fade in and out, but it's not as long as if you were doing something like a sine wave shaped envelope. So what could you do from here? You could try other shapes for the envelope, especially if you were to use a buffer, and then I believe the wave object would be good for this. You could send the phaser to wave that's set up to read from a buffer that has another envelope shape in it. You can look at the buffer help file. It shows you how to load up some different shapes. It's built-in function. It's pretty handy. So you could try that. You could try adding MIDI input that influences the pitch of the sample or where it's reading from in the buffer, or you could maybe have it so that every time you put in a MIDI note that it reads from a different place in the buffer. There's lots of possibilities of randomizing and playing with these different parameters. So I hope you found this useful, like usual. If you have any questions or clarifications, please let me know, or if there's anything else you'd like me to cover. Otherwise, until next time, class is dismissed.